Okay, so 3.6. So we're doing exactly the same thing that we did, just learned an hour ago. Okay, well, not exactly the same. We're just taking it a step further. Okay, so now if I show you, if we scroll down and it says factor these, okay. So the difference between what we just did and this one is that there's no divisor. It doesn't tell you what the divisor is. Okay, so what we just did, they give you the dividend, and they give you the divisor, and they say, see if it's a factor. Okay, and this one now is we don't have a divisor, so it wants us to factor. Okay, so we're gonna have to come up with the divisor. Okay, so I'll show you how to do that. Okay, so coming up with the divisor is we're using the factor theorem. I'll show you that with an example. So once we find out what the factor is, then we can divide, and then we can factor fully. Again, I'll show you with some steps. Okay. Okay, a binomial is a factor if there is no remainder. That's what this is. So if the remainder is 0, then we know it is a factor. Okay. You guys could go through this. So it is a factor if f at a is equal to 0. So I'm going to show you what it means. So in the last lesson in 3.5, I said here is the quotient. Sorry, here is the dividend. Here is the divisor. Tell me if it is a factor. So what you guys just did is you did long division or you did synthetic division to see if the remainder would be 0. Okay? If it was 0, then it is a factor. If it's not 0, then it's not a factor. Okay? We just did those. There's a shorter way to figure that out. Okay? Without doing all the long division or the synthetic division, there's a shorter way. And the shorter way is I could just plug in this number into the equation. If it gives me an answer of 0, then it is a factor. Okay? So that's what the remainder theorem is. So if I take this number, the opposite though, imagine this was in brackets. If we put that number into the equation, if it equals 0, then it's a factor. Okay? Just like an x-intercept. You plug in x-intercept into the equation, it's going to give you an answer of 0 because your y has to be 0. So we're going to take this number, we're going to plug it into the equation. If it equals 0, it's a factor. If it doesn't equal 0, it's not a factor. Okay? So what number am I going to plug into the equation? 2. Positive 2. So I'm going to do f at 2. So I get 2 cubed minus 6, 2 squared, plus 11 times 2 minus 6. So we're substituting 2 into the equation. So we get 8. 4 times negative 6 is negative 24, plus 22 minus 6. 8 minus 24 is negative 16, plus 22 is 6, minus 6 is 0. Much, much easier. Right? Instead of actually going through the whole steps of long division and synthetic, you can substitute that number in, and we can see if it comes up to be 0. Okay? The only problem is if it was like 2x minus 1, and it says if this is the divisor, you actually have to go through the process. Or, actually no, you don't. What would you plug in? What would you plug in if this was the factor? Artemis? Or 1 over 2, right? So it's just make it equal to 0, solve for x, you know, 1 over 2. Or you take this number, it's this number over that number. That's it. Okay, that's the first one. Okay, number 2, state the remainder when x minus 1 is divided into the polynomial given above. We're given next there. So same thing, we're going to substitute a value into the equation, and whatever the answer is will be the remainder. You do not have to put the zeros here. Okay, you don't need to do 0x squared So what number are we substituting? What number? 1. Substitute positive 1. So we have f at 1. Well, it doesn't say it's a function. So negative 4 times 1 cubed plus 2 times 1 squared plus 5. So it's the remainder theorem, right? So you plug the number in and give us the remainder, whether it's 0 or a number. So we have negative 4 here, positive 2, positive 5, answer of 3. Okay, so state the remainder is 3. Any questions with that? Okay, yes, just a minute to take that down. Okay, when we are factoring, so going back, grade 10, grade 11, and we're bringing back stuff that you should have already known. Okay, what is the first step to factor always? Always, no matter what type of factoring, you always have to do something first, or at least look for something first. What is it? Valentina? Yeah, so you're always looking for a greatest common factor first. Whenever the question says factor, that's the first thing you should always look for. Okay, because there's going to be multiple questions in your homework where you have to do a GCF first. If you don't, then you're going to look at your answer like, well, this doesn't make sense. Okay, so greatest common factor always. Always, always, always. Okay, do we have one here? No, we don't. Okay. They don't all have x's and they don't all have numbers. Okay, so there's nothing we can factor out of here. Okay, that's the first step. Now, well, we have an x to the power of 3. We haven't learned anything with the x to the power of 3. We haven't done that last year. If you did, it was probably a greatest common factor. You took out an x and you're left with a quadratic. Okay, so we can't factor by any method that we've learned previously. Okay, until now. So we just learned in the previous, we're dividing polynomials or you're factoring. Okay, so we divided to find the answer, but the question gave us what to divide by. We don't know what to divide by now. Okay, so we have to find that. We have to find the divisor. We have to define the divisor. Okay, and this is how we do it. And it's trial and error. It's trial and error. That's the best method we have. You're going to plug in factors of -6. Factors of -6, you're going to plug into the equation. If you plug it in and it gives you an answer of 0, then we know it is a factor. Okay? So, let's say this positive 6. So what are factors of 6? Any factors of 6? What can 6 break down into? 3 and 2. Okay, so it could be a 3, it could be a 2, and it could be plus or minus. Because it could be a positive 3 and a negative 2, be a positive 2, negative 3. Okay, any other options?
1 and 6.
You guys see that? 1 and 6, okay, or 1 and 6. Okay, so we have 8 options. 2, 3, 1, 2, 3, and 6, plus or minus. So, given that it's an x cubed, 3 of those are going to be factors. But we just have to find one. Have to find one. Which one should we start with? One of those numbers, which one would you start with if you had to find a factor? Use the easiest number possible. 1. Okay? So let's do this. We're going to plug in 1 into the equation. If our answer is 0, then we know that as a factor. So let's plug in 1. So I have 1 cubed minus 7 times 1 minus 6. I'm just doing this. Some of you guys can probably just do it in your head or do it in your calculator. So I get 1 minus 7 minus 6. Well, that one's not going to work. That gives me negative 12. Okay, so 1 doesn't work. You don't need to copy that out. Okay, what's the next easiest number I could use? Like? 2. Even easier? Negative 1. Let's go negative 1 now. If I go negative 1, I get negative 1 plus 7 minus 6, which gives me 0. Isolation room. Isolation room. Go to the washroom? Yeah. Okay. It's an isolation room. You're sick, COVID. She's a good. She wasn't impressed. Okay, so we plug negative 1, we get answer 0. That means the negative 1 is a factor. It's an x-intercept. Okay, so we know our first part of this is x plus 1. I put plus 1 because when we remove it, it becomes negative 1. Okay? So this is our first divisor. Okay, so the first one I'm going to do long division, and the next one I'll do synthetic. You can do any method you want. Okay, so we have to divide. So we have x plus 1, and then we have x cubed. Make sure, what am I looking for too? I have to make sure of what?
It's in order.
In order, decreasing, right? So we have a 0x squared minus 7x minus 6. Okay, so what number can I multiply x by to get to x cubed? Artemis?
X squared.
X squared. Good. So I get x cubed plus x squared. So our x cubes cross off. 0x squared minus x squared is minus x squared. Carry down negative 7x. What do we multiply x by to get to negative x squared? Artemis again?
Negative x.
Negative x. Negative x times x is negative x squared. Negative x times 1 is negative x. x minus a negative x, sorry, negative 7x minus a negative x, so it's negative 7 plus 1, which gives us negative 6x. And we know the answer should be 0 because we already tested it, right? So if it's not 0, then it went wrong here or there. And what's my last multiple? What do I multiply x by to get negative 6x? Someone other than Artemis? Michael?
Negative 6.
Negative 6, good. No offense.
It's okay.
Alright. And they all cancel out. So we get a remainder of 0.
Do we have to write some kind of like therefore statement or something?
We're not finished yet. We're not finished yet. I know in the textbook on those, they write it there, therefore they say, oh, so the quotient, quotient of this and this from the dividend and the divisor is such, right? You don't have to. That's the word.
Are there multiple possible divisors?
There's multiple divisors. Yes, there is. Okay, she asked, are there multiple divisors? Yes, there are. Okay, we only found one. It's an x cubed, chances are going to be 3. Okay, so now we have to find the other two. Okay, not by doing this. Okay, so now, so this was our original equation. So now what we're left with, so we have x plus 1, and we have this now. X squared minus x minus 6. Because when we divide, we factored. We're factoring. You okay?
Yeah, I think my water just went out.
Okay. Okay, so what we actually did there is we factored, from here we factored out an x plus 1. And now we're left with a quadratic. X squared minus x minus 6. So the question says factor fully. We didn't factor fully yet. We just factored once. What do you think we have to do now? We could do all this again. That takes too much work. Amanda?
Plug in and
Nope, easier than that. No plugging in. Sorry? Factor. Let's factor this. So now we have it down to a quadratic, which is, you guys should be experts by now, grade 10 and 11, how to factor a trinomial, a quadratic. Maybe you guys completely forget, but we'll go through it. Okay? So I'm going to factor this. Okay? So this is a simple trinomial. It's a simple trinomial because there's a 1 in front of the x squared. So all we have to do is two numbers that multiply to negative 6 that add up to negative 1. So what are two numbers that multiply to negative 6 and add up to negative 1? Samantha?
negative 3 and 2.
Negative 3 and positive 2. Good. And then we put an x in each of them. And now it's factored fully.
So the 3 and the 2 and the 1, those are all, so if we plugged in any of those at the beginning, we would have ended up.
Exactly. So if I plugged a negative, if I put a positive 3 here at the beginning, I would have got a 0. But I would have worked with an x plus 3 here. Sorry, x minus 3 here, and then would have gave me a quadratic, and then my quadratic would have factored into these two. Likewise, if I plugged in a negative 2 here, I would have got 0. So I would have had x plus 2 here. And when I factor, the quadratic would then factor into those two. So yes.
And because it's x to the power 3 at the beginning there, it's
3 factors. Oh yeah, almost always it'll be 3 factors. Almost always. Sometimes you might get the same factor twice. So you might get x minus 3 and x minus 3, which is x minus 3 squared. Okay? So yeah, you should have 3 brackets. Power 3, 3 brackets. Power 4, 4 brackets. Okay? Power 4s are long, because you have to do this twice. Okay, let's go to the last. Do you guys want to try the last one? I'm going to give you a hint though, because 56 has a ton of factors. Like 56 breaks into 56 and 1. Then it breaks into 28 and 2, 14 and 4, 7 and 8. Okay, so it's a lot of them. I'm going to tell you right now, 2 works. Okay? Because you would have done positive 1, negative 1. It wouldn't have worked. So 2 works. Okay, so I want you guys to start by using 2 as your divisor. If you want, use synthetic because it's faster. And it's already done. The exponents are all there. So I said x plus 2, so you have to plug in plus 2. Shouldn't switch it here though. It's supposed to be negative 2. Sorry guys. In my note, I just did a rough note here and I put 2, 4, and 7 work. It should have been negative 2. I think, wait. No, wait. Did I mess it up? Oh, it is. It is. What did I do wrong?
Instead of that, you brought when you brought the 1 down, it's supposed to be 1 up 2.
Oh, stupid. Thank you. Oh my goodness. That was right. Okay. 1, 2, negative 11, negative 22, which gives me 28, 56, and 0. Okay, good. So when you get here, but when I put it back into the bracket, it's negative 2 here. And then this is 1x squared, negative 11x plus 28. So x squared minus 11x plus 28.
So you don't switch the sign on people?
You switch the sign here. Like if you plugged in a positive 2 here, then you keep positive 2 for synthetic. If you did long division, you would do x minus 2.
Okay.
It's kind of confusing, because when I did the first one, I said which one worked? Negative 1 worked. But when I did long division, I put x plus 1, because that was the whole bracket.
But even in that example that we did,
Mm-hmm.
it was x minus 4, and then you put just positive 4.
Where? Here?
And I was like, yeah.
Yeah, x minus 4 in the bracket. When you remove it for synthetic, you put positive. For synthetic, you change it. Synthetic, you change it. Long division, you don't. Like from the bracket, I mean.
Yeah.
Okay. So now here, we get the quadratic. So two numbers that multiply to 28 and add up to negative 11. And negative 7 and negative 4. And then in the next chapter, we end up saying what are the x-intercepts. Then we take it one step further, and your x-intercepts would be 2, 7, and 4. But that's next chapter. Okay, I want to fix something on the homework. I don't want you guys to do number 1. Scrap this. I just want 4 to 7. So 4 to 7. 9 and 10. So let me double check in my textbook. Page 176. Yeah, definitely not 8. Definitely not 14. Yeah. So 4 to 7, 9 and 10. Okay, that's the homework. Yes?
Like all of 4? Or
Yeah, do all of them. Yeah. Yeah, it's better. Like if there's a bunch A to F, do you have to do every single one? Am I checking it? No. The more you do, the better you'll be off. And remember, I put homework questions on the test. So if you're doing those, if you're skipping, then I might put a question that you skipped on the test, right? So it's up to you.